I'm talk about immune responses now. To really go into immune responses, you have to know the lymphocyte. The lymphocytes are found inside your lymph. So lymph does mix with your blood. It's kind of the fluid around your body. There's two different types of lymphocytes. There's T and B. T stands for the active type, where B stands for a builder type, but they're each related to a different immune response. Now, here are the two immune responses. You can pause the slide, look into this more if you want to. There's what's called the humoral response and the cell-mediated response. I'm going to go over these later, but again, this slide is really helpful to explain it out. There's one other thing I need to go over, and that is the understanding of glycoproteins. I know we've talked about this before, but just to remind you, outside of every single cell, there are these little sugars on these proteins that we call glycoproteins. Now, also on pathogens, you will see glycoproteins. So this is our COVID-19 that we're dealing with. They happen to have these glycoproteins on the outside of it. So when we talk about T cells, also known as T lymphocytes, any type of antigen from here on out, instead of saying glycoprotein, I'm going to be saying antigen. Whenever there's an antigen recognized that is not good, a T cell will then come over to that pathogen and render it inert. They will either engulf it, break it down, they'll somehow puncture it, and this is why they are sometimes known as killer T cells. This is called the cell-mediated response because the T cells will mediate whatever's coming into the body. The other one is the B cell, known as the B lymphocyte. B cells, as they are builder cells, are actually going to create antibodies. When what's known as a helper T cell presents one of those antigens to the B cell, the B cell will then be able to create specific antibodies to stop that pathogen in its tracks. And this is known as the humoral response. Antibodies are, very simply put, they're Y-shaped proteins that will actually attach to antigens of any foreign pathogen. They cause pathogen clumping, and this is what's going to actually break down that. Let's say it was a virus or something coming in. It's really important that your body has these antibodies if you want to fight invading pathogens. Another thing that happens is what's called memory B and T cells. Let's say you just got sick and now you're recovered. Well, for a brief window of time, you'll have what's called memory T cells. These cells are going to actively fight anything that comes in. However, for up to like a decade or maybe even two, your body will hold on to memory B cells. So that way you can always have those antibody producing cells if you ever get infected again. This creates immunity. So when we talk about a vaccine being created, you literally need to provide the body with a certain number of antigens so that way memory B cells can form. So that way you have as much immunity as possible. Once those memory B cells form, you have immunity. So looking into the real world right now with COVID-19, it's really tough because there's so many glycoproteins on the SARS virus that we're looking into. The coronavirus, we want to make sure that we have all of them locked down before we give out a vaccine. Because if we even miss a couple of these glycoproteins, then the coronavirus will come in and will actually activate as if there were no immunities at all. So trying to make a vaccine is tough. Right here, you can pause the slide, read this. We are currently investigating this right now to like this month. We're trying to get all those glycoproteins down to activate T and B cells in your body to create a vaccine, but this is going to take some time. All right, you can pause the slide, but this is going to relate to your assignment and what I want you to do but after you end this video. All right, I hope you have a good day and take care.